Hi, everyone. Welcome to Seed's webinar, workshop today, and thank you for joining Imagine 2022. This video is being recorded. It will be on YouTube here in a little while. We have Lakshantha from Seed who will be presenting today. There is a Q&A feature for this workshop. It's down at the bottom of your Zoom application. Please submit your questions there and we'll answer them at the end of the presentation. Lakshantha, thank you.
Thank you, Josh. Hello, everyone, for this workshop. So this workshop is about training and deploying your own AI model into a vision AI sensor. So before moving on, I will introduce a little bit about myself. I'm Lakshantha, and I'm an application engineer at Seed Studio. So I have worked in the industry for about 4 years now. And my main areas of focus are IoT, embedded systems, and AI. Also, I have worked as a Udemy instructor in the past. So if you want to connect with me, you can check my LinkedIn and Twitter. Also, if you visit my GitHub, you can check all my works. So talking a little bit about Seed Studio. So Seed Studio is an IoT hardware, open source IoT hardware manufacturer, which manufactures open hardware ranging from a lot of sensors and single board computers to AI and IoT enabled devices. So we cater devices both to makers and also to industries. So as you can see, we also manufacture industrial sensors and devices as well. So we started in 2008, and so far we have around 2,095 plus kind of modules, spanning over directly serving around 350,000 users, and also for the industrial applications, we partner with different companies to better serve the community. So, and also we provide the agile manufacturing services where you can start from a prototype and go to a mass production in very little time. So we also provide that service. So these are some of the hardware that we manufacture. So we manufacture a range of different sensors that can monitor environmental conditions like temperature, humidity, soil moisture, water levels, and also gas sensing. And also different kinds of communication sensing devices like Wi-Fi, Bluetooth, cellular, LoRa, and other. Also, we manufacture main boards such as the ones based on the Raspberry Pi compute modules, and also the NVIDIA Jetson platform. So there are some x86 boards that we manufacture as well. So for all these devices, we also do enclosures, industrial enclosures, such as this, which are suitable to withstand different industrial conditions, such as like harsh environmental conditions and others. So that's about it, about the introduction about Seed Studio. So if you want to learn more about Seed, you can visit seed.cc or seedstudio.com. So now let's look at the evolution of edge AI devices, right? So NVIDIA is a well-known company who focus on AI applications, focus on manufacturing devices for AI applications. So mostly we will use a platform like the NVIDIA RTX platform. So this is the latest, the RTX 4000 platform, which got released recently. And this kind of device can really do a lot of AI inferencing. But now, as time moves on, we are trying to get into making the device as small as possible so that we can do the AI at the edge in very small spaces. So for example, NVIDIA has their own single board computer platform, which is the NVIDIA Jetson platform, right? So it is much smaller in form factor compared with the big PC GPU like this. So this kind of platform has like NVIDIA Jetson Nano, Xavier NX, AGX, Xavier, like different kind of modules are there. So moving even much smaller from this device size is the MCU platform. So for the MCU, we have the VIO terminal. So this is a device by Seed. So this is also able to perform some level of AI inferencing on device. So even moving further smaller from this device is this kind of MCU module, the Grow Vision AI module. So this is the type of so this is the main focus for this workshop today. So this is the device that we will use to train an AI model and deploy that model onto the device and perform the inference on the device itself in such a small scale. So when looking at all this, like from this big PC GPU to this very small MCU, when the device size gets smaller, sometimes you would need to compromise on the accuracy and the inference performance of the model, right? Because you can never run a model which is designed to run on this big GPU on this small device. So because of this, now new AI algorithms are coming out. So for these kind of small low hardware resource devices, there are special optimized models, AI models to run on these devices. And actually, Edge Impulse has some models to perform on these small devices. So that's what we're going to discuss in this workshop today. So talking a little bit about the Grow Vision AI module. So this is, so I have the Grow Vision AI module with me. So as you can see, it's a very small device. It's a very thumb size. It's very small. It's around 40 millimeter by 20 millimeter is the PCB size. And it's powered by a HiMax chip with 400 megahertz DSP. And it has an onboard camera, small camera with 1600 by 1200 resolution. And it consumes very low power. Also, it supports object detection and image classification models. And not only it has the camera on board, but also it has an onboard microphone, a 6-axis accelerometer on the device. So if you want to connect this device with another microcontroller, for example, like this can work standalone as well. But if you want to connect to another microcontroller, maybe based on Arduino, you can connect to it using this Grove connector at the back of it. You can directly plug this connector to another Grove compatible platform, microcontroller platform, to communicate with this device. So if you want to learn more about this Grow Vision AI module, you can visit this wiki page, or else you can scan this QR code to access it. Yeah, so I'll give a couple of seconds. Okay. So this is actually, I will just briefly go through this module because this is the main focus of our workshop. So this is the main chip, the HX6537 chip, and the camera connector, the DC-DC chip, and the Grove connector, which I mentioned before. There's a power light and a burning indicator light. Because this light will be used when we, when we use this module, we need to flash different AI models into this device. When we, after training on the Edge Impulse Studio later on, we had to flash the firmware to the device. So when we flash it, this kind of LED light will keep on blinking. So that's the indicator light. And it has a BL702, which is the USB to UART adapter. So this is the mic and the 6x6 accelerometer, as I mentioned before. It has SPI flash, Type-C connector, and then it has 3 buttons: the reset button, boot button, and the user button. So we will use these buttons later in this workshop. So what ML algorithms can it run, this device? So actually, out of the box, when you buy this Grow Vision AI module, it's preloaded with a model which is trained using Ultralytics YOLO V5. So that is what comes out of the box. But we recently partnered with Edge Impulse to integrate edge impulse models, such as the FOMO object detection model on this device. So because we thought that the FOMO will perform much better when compared to the YOLO V5, because a model such as YOLO V5 is mainly optimized to run on other heavy platforms, like not very MCU based devices. So that's why we did this collaboration, and now we already started the integration with Edge Impulse together. So as you know, FOMO is mainly FOMO is an object detection model mainly optimized to run on this kind of small MCU based devices. So this particular Grove Vision AI module, it actually comes as part of this particular SenseCap K1100 sensor prototype kit. So this, you can see that this Grove Vision AI module is part of this kit. So if you are interested in getting this kit, you can actually build very interesting projects using this kit, because it has a VIO terminal. It is a microcontroller with an LCD on board, and also the Grove Vision AI module itself. And then it has some gas sensor module, a temperature and humidity sensor module, a soil moisture sensor module, and another Grove LoRa E5 module. So by using this LoRa E5 module, you can connect all these sensors together to this VIO terminal microcontroller, and then send the sensor data to a LoRaWAN gateway. And then from that gateway, you can send the data to the cloud to visualize all the data on a dashboard. So that is the kit. And if you're interested in that kit, you can visit this URL to learn more about this K1100 kit. So now let's get hands-on. So when you buy this this module with the kit itself, the K1100 kit, right? So this module comes with a people face detection model already pre-installed on the device. So as I mentioned, we use the YOLO V5 to train the model out of the box, and it's so I will just briefly show that how it runs on the device. So this is already flashed with that model, with the face detection model, with the people face detection model. And what I will do is I will okay. So before that, I'm sorry. Before that, so this is the firmware which comes with this kit when you buy this kit. So if you go, okay, let me share my screen. Okay. If you go to this this GitHub repo, Seed Studio SenseCraft GitHub repo. So this is the firmware which comes with this kit pre-installed. So by using this firmware, you can sense the data, process, and send to the LoRa cloud. So let's check this releases, right? So if you go to the releases, we can see that there are some latest releases, because right now you might not, if you have this kit, you might not have the latest release. So if you want to flash the latest release to this board, what you need to do is you need to first click on this UF2 file. So that's the pre-compiled UF2 file, SenseCraft version 0.3. And then you take the module, you take the VIO terminal, power to the computer using the USB Type-C connector. You connect to the USB Type-C connector, and then this button is to turn on the device. The button on the side. So you just turn on once, and then you need to enter the bootloader mode. So to enter the bootloader mode, you need to press this down 2 times, this button 2 times, 1, 2. So when you do that, it will enter the bootloader mode so that we can flash that .uf2 into this microcontroller. So when it enters the bootloader mode, it will show this particular VIO terminal as a USB flash, USB mask storage device on the computer. So if we go back, if we go here, we can see that it already created this, loaded this USB drive. So what we need to do is we need to copy this version 0.3 SenseCraft firmware into this this particular USB drive. So once we do that,
Hey, Lakshantha, I'm sorry, but
yes,
the video is not coming
yes.
through.
It's not coming through.
Mm-mm.
Oh no. How about now?
Unfortunately not.
What can you see now?
Just a blank screen. Perhaps if you reshare our webpage of some of the steps that you walk through. This is a very common activity that we do with Seed Studio. Now we have a
What do you have now?
we see a file explorer window.
Okay, now it's good. Now
Yes,
it's good.
yes, and I can see
How
the
about
UF2
now?
file. Yes.
Yeah.
Yep. All good now.
Okay. So
you might need to back up 1 or 2 steps.
Yes.
Mhm.
Okay. So did you see the booting this device like going into the bootloader mode?
Correct. Yeah,
by
you'll have to
pressing
double
down
click.
this button, double click the button, and then it will enter the bootloader mode. So once it enters the bootloader mode, it will show this. Can you see this Arduino?
Yes, yeah, we can see the
Okay.
mass storage device. Correct.
Okay, so so this is the mass storage device. So you need to paste that UF2. So let's go to downloads, and the UF2 that we copied, downloaded from that GitHub repo, and then copy into this drive. So once the copying is finished, it will just sorry. So it gets disappeared, right? That screen gets disappeared
Yeah,
once
because
it gets copied. Yeah. So that's how you can check whether that has successfully flashed into the device, right?
Correct.
So
Yeah, with Zoom,
when the drive gets disappeared.
yeah, for others here, right, on Zoom, we can only share an application window. And so after you drop the UF2 file to the device, right, that actually programs the device will then disconnect because it's going to reboot, right? Windows will disappear the window, and therefore Zoom goes to blank screen. So the device is now successfully programmed though. Yeah.
Okay. So now what we do is this kind of Grove cable comes with this kit, right? So we connect this the right side, the right side Grove connector to this port, right? We connect to this one, and then we just connect this. So as I mentioned before, this can you can easily connect, you see, using the Grove connector, this connector, to other microcontrollers, so such as the VIO terminal that we are connecting now. So we connect to it, and then so what we need to do, what we need now is a preview, right? A live preview. So for a live preview, so you need to connect to a USB port as well, and then connect to the computer. So once you do that, so you see there'll be, can you see this small window, this small box? Yeah.
Unfortunately, no, we only see the just on the page. Oh yeah, sorry, the small box now has appeared. Yes. Okay, that's a small box which appears as soon as you connect this device to the computer, right? So you click on it, and it will open up a web page. So I'm sure, can you see the web page? Yes, the web page is coming through. So you click the connect, and then you select the Grove AI connect, and it will start the video stream. Okay. It should detect my face. Okay. Oh, it's not detected. Okay. I think the light is not good enough. Let me check again.
So it's very dark here. Okay. Yeah. So as you can see, so that's the detection. So this 64 means the confidence. That's the 81% means the confidence score. So 79%. Yeah, that's its confidence. So if it's well lit, it would have a much better accuracy. Yeah. So this is what you get out of the box when you get the K1100 kit with the Grove Vision AI module together. Yeah.
And this is out of the box, you know, as you get shipped from Seed.
Exactly. Yes. Yeah. So actually, that sensecraft.uf2, right? The GitHub file that I just uploaded. You don't have, if you buy the kit, if you have bought it recently, you don't have to even do that. You just plug it and it will be ready to go. So I just showed you in case it's not available. The latest firmware is not flashed on the particular kit that you bought. Maybe you bought it a few months ago. Yeah. So that's why I showed you that.
Yeah.
But if you buy it recently, it's just there, ready to go.
Yeah, Lakshantha, we do have one question. Is a mass storage device and the transfer operation available on Macintosh?
Yes, it is available. Yes. So on the Mac also, it will just show as a mass storage device, just as on the Windows, and also on the Linux, the same. Yeah. Yeah.
All right.
Yeah. So okay. So moving on.
And then we did have one more question just about this particular section. I feel that this would be relevant to answer here. Somebody had asked, how much does it have to be in a straight line of sight? And at what distance does it detect? What they're referring to is the camera. And how closely do you need to get it aligned to see a face, which is relevant to the model?
Okay.
And then how far away does it work?
Yeah, actually, for the exact distance, it depends on the lighting conditions as well, right? So it's well lit. It will be good for a couple of meters, maybe 10 meters. And like, it depends on the lighting conditions also. And also on the model. So currently the model that we use is pretty accurate. It's trained on a data set of about 7,000 images. About 7,000 images. So it's pretty accurate, the model. And you can come close or even go far away. But for the exact threshold, like of the distance, I cannot really, say that value. But it will be a good couple of 10 to 20 meters should be fine. Yes. Yes.
Okay. Yeah. If you'd like to continue. Yeah.
Sure. So moving on. Okay, so I'm sorry, I need to switch between many screens. Okay. Okay, so we did this, and this. Okay, now moving on to the edge impulse experience. So far, what I explained to you is about the out of the box experience, right? So that is when, if you have the access to the K1100 kit. But as I mentioned before, you don't need a microcontroller to use with the Grove Vision AI module. You can use it standalone as well. So for this standalone experience, we partnered with Edge Impulse, as I mentioned before, to integrate the Edge Impulse models into this device. So so far, this is what we have achieved, because we started with Edge Impulse a couple of weeks ago. So we didn't have enough time to finish the complete 100% integration with this particular module. But that 100% integration will come very soon. So far, what you can do is you can. So if you guys are familiar with Edge Impulse Studio, right? So in the studio, you can collect data from the studio. So there are different ways of collecting data on the studio. One way is to collect using the mobile phone, or like we can use the webcam to collect data from the studio, or else if you want to collect data using the Vision AI sensor, that is not possible at the moment, because that is something that is not done yet. As I mentioned before, that's not fully done. So but if you want to upload data collected using this particular camera module, I will show you later how that can be done for now. And after that, after doing the data collection, you upload the data. You can annotate the collected data, or else you can upload a public data set to the Edge Impulse Studio. And after doing that, you can train on the Edge Impulse Studio, generate an AI model, flash the AI model to the Grow Vision AI sensor module, and then run this command to weave the inference. So that is the object detection, live object detection can be seen on the web browser. So this is actually the full experience. So the difference between the experience right now and the full experience is only about this part. As you can see, this building and training and deploying stays the same, but this is different. So how is this different? So when we integrate this fully with Edge Impulse, you will be able to connect this module and then upload a particular firmware to this module. And then when you do that and connect the module to the PC, the Edge Impulse Studio will recognize this device as an official supported Edge Impulse board. So once that is detected, this particular camera module can be used to collect the data right from the Edge Impulse Studio, and then do the annotation of that collected data, train, generate, do the same thing again. So this is the only part that we will that is remaining for now, which will be implemented very soon. So what do we need? So first we need a Grow Vision AI module itself. We need this one. And then we need an Edge Impulse Studio account. So let's head over to Edge Impulse Studio now. So I will go to Edge Impulse Studio. So you need to visit this. Okay. So you need to visit studio.edgeimpulse.com. This URL, studio.edgeimpulse.com, and then you need to sign up for a new account if you don't have one. But if you already have an account with Edge Impulse, you can sign in to your account. So for my case, I already have an account. So I will, I'm sorry. Okay. So this is the, sorry. So this is my account, Edge Impulse Studio account. I already signed into my account. And then let's create a project. So let's name it as face detection. Okay. And then now what we need is okay. So here you need to specify this. So the labeling method, you need to change it to bounding boxes, because we are doing an object detection project. Because in Edge Impulse Studio, you can do two different projects. One is the object detection project, and the other one is the classification project. But we are interested in the object detection project, where you can detect object in many objects in one particular video or an image. So we select that, and then we go to this part, data acquisition part. So this is where we collect the data. So in here, click on this, let's collect some data. So as you can see, there are many options to collect data. So the first option will be available once the fully integration is finished, as I mentioned before. So it says connect a fully supported development board. So that will be available later, when very soon. And next is the using the mobile phone, using a computer, or also uploading a public data set. So you can also do this if you don't have, if you don't want to annotate data by yourself, you can also upload a data set which is already annotated, which is already prepared and annotated. So for this workshop, for demonstration purposes, what I will do is I will collect data from my computer. So from the webcam on my computer, I have another, I will use my other laptop. to collect some data. So I will use this account. Switch to my team viewer here. Let's see. Okay. Okay. So this is the this is the project that we just created, the face detection project. And we go to data acquisition. So actually you can use the mobile phone as well, right? Because when we go to this, we can see that you can use the mobile phone. But I want to collect some data to detect the face. But when you use a mobile phone, you can only use the rear camera at the moment, but the front camera cannot be used. So, but I think that that's a small bug. I think that will be fixed later in the studio. But for now, it will be much easier for me to use the webcam on the laptop to collect some data. So I use the computer, and then we need to collect images. Okay, so you need to give permission to access the camera. Okay, and then change this to training, right? We need some data for training. So we'll collect some data. This capture. So as you can see, when you capture that, it gets recorded just after capturing from the web camera. Okay, so we will capture around 20 images. 3, 4. Change the angles maybe, because we need to capture in different angles. I think 15 is enough for now. Okay, let's do 5 more. 16. Okay, so we got 20 images now. So all these 20 images are now can be seen over here. Okay, so now next we need to label these images, right? So for labeling, I will come back to my other screen. This one. As you can see, everything gets updated instantly, right? So now I'm on my other computer. So to label the data. So now let's quickly label this data. So go to this this part, labeling queue, and then you select this label suggestion as okay, cannot be seen. Track between frames, right? Because we are only labeling one particular face, right? But if you want to label many different objects in the image, you need to select this one. It will help you label better, but this will track your labeling. So I will quickly label. Okay, sorry. My face over here. So I will give a label name. Save labels. So as you can see, it tracks your next face. You just need to click save. Okay, this is also good. So as you can see, you need to adjust a little bit over here. So when we are labeling, you need to make sure that this particular box is covering all the boundaries of the object that you want to detect. So for example, for my face, so this, so if you do like this, it's not it will not be accurate later on when we are doing the inference. So you need to make sure that you make it tight. The labeling should be tight. Okay. So doing some adjustments. 16. That's good. It's good. So here I'm not including the headphones, just my face from here. So actually, I use 20 images just for the sake of this workshop, just for demonstration purposes. But in reality, 20 images will not be enough at all to build a sufficient training, sufficient model for detection. So because for now I will use myself to detect. So it will not detect other people, but me myself. So for this it will be fine, but for other kind of detection you might need like to collect around 150 images should be okay to start with. But more the images, more the higher the accuracy will be, like 400, 500, 1000. There are more images, the accuracy will be much better. So we have 6 images left. Okay. We have 5 more. I think. Yes. We have 3 more here. So we got the last one. Yes, finally. That's the last one. Okay, we are done with 20 images labeling. So after that, you need to go to this impulse design tab. And then let's create an impulse. So for the input image size, we will use the resolution 64 by 64. So we have tested with this image size with edge impulse before, and this is an acceptable image size to use later on in the inferencing. And then for this processing block, we will use the image block. And for learning block, object detection block, because we are doing the object detection task. And then we save the impulse. After that, we go to this tab, image. We save the parameters. And then we generate features. So to perform this, it will take a couple of seconds. Wait some time. Okay.
I could give just a quick background of some of the steps Lakshantha just accomplished here, right?
Yes.
Creating the impulse is a couple different blocks, right? Where your data acquisition sources from, a processing block, a learning block, the output, right? When generating these features, while I may not look like it's doing much here for the image, for other applications, things like audio or vibration, these processing blocks become very important, from which, you might have to do different spectral analysis features and things like that. For here, this particular block, what it's doing is taking, what might be a full-size high-resolution camera image and shrinking it down to, I think Lakshantha chose the 96 by 96 feature output, right?
Yeah, 64,
That feature,
yeah.
right? Oh, 64, sorry.
Right.
The 64 by 64 image is what will be fed to the learning block essentially to train against, right? And when you eventually run on the device, right, the camera is taking a full resolution image, the processing portion of the code, we'll shrink it down and then feed it to the model. And that's to give, faster inferencing and not to make the model blow up to be, a couple megabytes, right? You don't need every single little pixel in order to do face detection, for example. And that's how you're able to get some of this really good performance on small embedded devices.
Right. Thanks, Josh, for the explanation. Okay, so let's move on to the object detection block, this tab. And then this is where we start the training process. So let's keep it at default settings. So this is the number of training cycles is 60, learning rate 0.001, validation set size. We will all keep it at default. And then this is where the object detection model comes into play. So by default, Edge Impulse already includes the former object detection model over here, as you can see. So if we go into this, you can see some other models, the MobileNet V2 SSD. And this is another former model, but it looks like that's an old version of the model. But this 0.35 is the latest version, and it is already added over here as the object detection model. So what we need to do now is we need to click this button to start the training process. So for this training process, it will not take a lot of time because we specified the image size as 64 by 64. Training for 60 training cycles. It will take around 1 to 2 minutes. It will take less than 2 minutes. Yes, about 1.5 minutes. Yeah.
I can make a small correction.
Yes.
The different options for FOMO, such as 0.1 and 0.35, are not so much versions. They are different versions, but they're not chronological versions. What they represent is the alpha feature of the MobileNet base model. So FOMO
I'm
is
sorry
basic.
about that.
No, it's okay.
Okay.
It's just to clarify a point, right?
Yeah.
So what alpha means in the MobileNet parlance, right, is just the number of filters that they have in each layer. And I can point to relevant documentation for that. Nonetheless, right, you can try out, I think the big point here is in Edge Impulse Studio, you can try out different models to see which gives the accuracy and performance that you need for your particular application.
Right. So maybe Josh, you can share those links with our audience.
Yeah, when the YouTube video comes out, we'll be putting some of that information as well.
Great.
And then we've had a couple of questions in the chat here that I've answered off on the side.
I think you can proceed because it's still training. Yeah, we are waiting here.
So one question I had here is how are you able to do that many epochs quickly? How we're doing training? Well, for this particular training cycle, on the number of epochs that we're running through, right? This model is only training against a very limited vision set.
Yep.
Obviously, if you import a set or have thousands and thousands of images, it will take longer to train against. What is going on in the background is we'll spin up, a server in order to do the computation time, and Edge Impulse has different levels of compute power available, and those options are available on the website. And you can kind of see the difference between, what you get free out of the box versus if you are a paid user.
And also, I think we are only detecting a single face. Like I only label one face per image. I think that also matters.
Correct.
If you label a lot of objects in the same image, that will also take a lot of time for the training process.
Yeah. And before we proceed, just one other question I didn't answer on the side here too is somebody had asked if you can detect multiple people, if there's, can the model only detect one? Is there a limit, and how does lighting affect everything? I gave a fairly detailed answer here, but I just wanted to just kind of comment on it. Different models have different features and capabilities. Ultralytics, YOLO V5 has had has different versions, and FOMO has different capabilities as well. So it's important to kind of know, what your application is targeting for, and do just a little bit of research about, which particular base model you go against. But your training set is extremely important. And what we're trying to do here with Edge Impulse is to give you the ability to make those comparisons to see what's right for your particular application.
Right. So now the training process is finished, as you can see. So Josh, yeah, you can see the score over here. So what we will do now is we will go to this block, deployment block. And then there are different options here. So first of all, I will show you how you can easily perform the inference on a computer or a mobile phone, right? So you can easily run this. So let's click on the computer. So for this part, I will use my other laptop because I will use the webcam in that laptop. So I will use the team viewer to access that. This one. Yes. Okay. So this one, you go to the. So this is kind of like to verify the model, right? Before deploying it on the device itself, you can easily verify it, how it will perform. So select the computer over here, and then click this button to build it. Sorry. Okay. So it's building the project. So actually, after building this, this model will run on the device itself. So it will use the resources. Like right now, it's running on the laptop. On my so it will use the hardware resources on my laptop. And if we use the mobile phone option over there on the studio, it will use the computing resources available on the mobile phone to do the inference. Okay. Should be good in a few seconds. Josh, are there any questions to answer?
Not at the moment. I think I've been answering just a few on the side.
I see some notification on the chat. That's not the questions, right?
No, notification on the chat. Some people were just commenting on the price that you had mentioned earlier. Yeah.
Okay.
Right. Oh, here's one question.
Yes.
Yeah, if you want to click through the permissions. How did you get the Vision AI module to show up under the deployment tab? Yeah. So the integration with
that's
Seed.
to talk after this.
Yeah. Well, we'll talk about that in a second. Just to give you a preview, right? That is not that feature is not live for the general public yet. We're still working on it and working out a few kinks, but it'll be available soon. But once that's available, we'll be sure to notify people and modify to YouTube, pointing out its general availability.
So you see, it's pretty good. It's doing a pretty good job detecting my face. So this is with only 20 images, right? So if you have more images, you can have a better model. Yes.
So this is running on your computer, right?
And yeah, that's running on my computer. Yes.
Yeah. Yes, and then we'll show some inferencing done on the device. Exactly. So that's to verify the models. After that, what we can do is, okay. After that, share my screen. So as Josh mentioned earlier, so this particular Seed Grove AI Vision module, right? Block, that's available for this workshop for demonstration purposes, right? But this will be available for public very soon, as Josh mentioned. Once we finish the full integration with the with Edge Impulse and this module. But just to give you a brief overview, right? So if you after building an object detection model using the Edge Impulse Studio, okay, you can see my screen, right?
So after, on the studio, you just click on this block, Seed Grove AI Vision block, and then you can analyze optimization. Josh, would you do this as well? Analyze optimization?
Yeah. So
okay, yeah.
The different availability, there's the Eon tuner and the Eon compiler, right? Well, your models typically come out of TensorFlow Lite, with a Float 32 version or an 8. Sometimes depending on the parameters that you give on the model, for example, if you chose a large input image size to the model, it may not fit on your device, right? As a Float 32, you may have to quantize it. When you do that, you might lose some accuracy, right? And so here we're trying to inform the user, right, that you might have to make some design trade-offs in order to run the model, right? In this case, like, hey, maybe you need to go change the input size, you might need to go configure things a little bit differently as well. That's what the analyze optimization is. You don't necessarily have to do that, but the key here is that this particular block, there's a number of deployment options, of which Seed Studios will have the Grow Vision AI as an option. In which case we're actually building firmware specific, and you'll get a UF2 file output. Of course, this is why we don't have it fully available, right? The job failed in this particular case, right? And so we do have some videos to demonstrate some of the functionality we're working on. We just started a few weeks ago.
Yes, that's right. But still, you can click on this tab to build the model, right? You can do that.
And then what will happen is you'll get an eventual pop-up with the zip file containing the UF2 file that you would copy over to the device. Exactly.
So you see that once the build is complete, and it there's a .zip file, as Josh mentioned, and what we need to do is we need to I'll go to that one. Can you see my full screen?
Yes, we see a file explorer window.
So we just extract, right? So when we extract it, we can see a .uf2. So you simply need, so this .uf2 contains the firmware and the object detection model, both on one single file. So you just upload this UF2 into the Grove Vision AI module, and then you can do the inferencing, right? So for that part, actually, I will show you this one. Okay.
This would be the drag and drop like you had demonstrated earlier, right?
Exactly. Yeah. Just like I showed on the Vio terminal before, the same kind of steps are performed for the Grove AI Vision module. So you can see this slide, right? So you just connect to the USB connector and then press this button, the boot button, twice. So just as we press the button on the Vio terminal twice, you press it down twice. The same way, we press this button twice to enter the bootloader mode. And then once you enter the bootloader mode, it will show a mass storage drive like before. And then you just drag and drop the UF2 that we downloaded from EdgeImpulse into the device. And once the UF2 gets flashed, the drive will disappear, meaning that the firmware is successfully flashed into the device. So this is how it works. So after flashing, so I have so our friend Matt from EdgeImpulse, he has prepared a small demonstration to show you guys how the model will perform on the Grove Vision AI module. So I will play that.
Yeah. While this is going on, right, there's no sound. Just a reminder, right, what we had shown on the phone, this is the same model, right? We didn't retrain it or anything. We just rebuilt it from a different device. So before you're running on the phone or computer, and in this case, we'll be running on the Grove Vision AI module. And again, this is a preview of what's to come. We don't have it publicly available yet.
Exactly.
Or generally
and one
available.
more thing. Yes. Sorry. Okay. I'm sorry.
It's okay.
Okay. Can you see my screen? Oh, sorry.
We see a presenter feature of the presentation.
Okay. I failed to mention one thing. So you need to install this also, EdgeImpulse CLI tools, to talk with the studio, right? You need that. So after you flash the firmware into the device, you need to run this CLI tools. So, okay. go to this one, show you here. Okay. So if we go here on the docs.edgeimpulse.com/docs, right? This URL, you can see that under the installation, Edge Impulse CLI, you can find how to install it. You first need to install Python 3 on the host computer, and then install Node.js version 14 or higher, and then simply execute this command to install the CLI tools. So this is very important if you want to use the tools. Yes.
Yeah, this tool is universal for all of our integrated devices, not just for the seed, right? So having access to this tool is important for if you want to test other targets. What this tool does is it'll communicate via serially to the firmware that you have deployed, right? So that UF2 file that we had just generated, drag and drop that on the device, right? Once that's running, you'll run the CLI tool, and we'll show that video here in a second. And then those two will talk to generate the images that you'll see.
Yeah, and also it supports, as you can see, macOS, Windows, Linux, Ubuntu, Raspberry Pi OS, a lot of different architectures. This tool is supported. Yes, I want to mention that. Okay, and then after this tool is installed, so we can run this tool. I can show you how this is running. You can see the PowerPoint? No?
Not yet. It's still on the web page.
Okay, now it's okay, right? Okay.
Now we see the video inside the PowerPoint.
Yes. Okay. So now this is Josh. You see, he just ran the command edge impulse run impulse /debug. So this is the command that you use. And then when you enter this command, it will ask you to enter the serial port, right? So you need to select the serial port, which is according to the Grove AI Vision module. So you need to select that port. So when you select that port, you can see here, oh, sorry. When you select that port, you can see there's a web browser display on the terminal. You need to copy and paste this web URL. You need to copy and paste this URL on a web browser. So that is to weave the inference. Yes, you can see his face being detected. This is all happening on the device. Okay, okay. You see? Yeah, this is happening on device. So as you can see, this time for inference, that's the inference time, is around 26 milliseconds. So that is actually very impressive, because 26 milliseconds inference time, if we convert to the frames of second, it's around 37 frames a second. So to run an object detection model on such a small device and having an FPS of about 37 is it's very interesting. So I also want to note that it's based on the 64 by 64 input image size, the train model that Matt just used. Yeah, and just another thing in the video, even though the inferencing time is 27 milliseconds, it looks like it's lagging, right? The video is kind of lagging. It's not very smooth. That is because we are sending the image over UART on 115200 baud rate. So that's just for the preview, right? That's just for the preview. But for the real inferencing, the 27 millisecond is the real inference time. So for example, if you want to integrate this into other applications, this is what you get. This is the inference time that you get. Yeah.
Yeah, typically for embedded applications, right, you may not be displaying over a serial connection to a web page, right?
Exactly.
And in which case there's an Edge Impulse SDK from which you can use, again, the same model to do the run classification or run inferencing function. of which you get the output, the confidence intervals and the different TensorFlow outputs that you need in order to make a determination of what exactly you're looking at.
Right. Yeah. So also, I want to mention this. EdgeImpulse also provides public projects. So if I go into this particular web address, edgeimpulse.com/projects, or else you can scan this QR code. If you go to this website, you can see a lot of community generated projects, public projects. Also, some projects are by EdgeImpulse themselves. So if you go to object detection, okay, so loading projects. So you see some projects are from EdgeImpulse. So let's look at one project. So this is an interesting project. So car parking occupancy detection. So this project, these community projects are already built and they're all ready to go. So what you need to do is you just click deployment and then build the firmware, upload to the device UF2 and done. That's it. So if you go to the data acquisition part, we can see these cars in a parking lot are labeled. And the training is already done. Everything is finished. And only the deployment part is there. So also when we open a public project like this, first we need to clone this project, right? There's this button called clone. So because as soon as you open this kind of public project, you cannot edit anything because it's public. So after you clone it only, it will come to your come under your account. So you just need to clone it. Yeah, can give a name and then clone the project. Yeah, so that's about the public projects. So and now this is the final part of our workshop. So we have come to an end. So some things that I want to highlight. Some bonus content for developers. So because so far what we have showed you guys is how to get started with the EdgeImpulse with Grow Vision AI module to perform the training and the inference and show on the web browser. But if so, the developer, if they want to get started with this, they want to have access to the source code, right? So to get so for that one, we have the source code available here, but that is not yet public, right? As we discussed before, some things are not public at the moment, but they will be public soon. So I will quickly go through this this repository. This one. So this is the, sorry. Yeah. Okay. So this is the repository containing the EdgeImpulse firmware for this Grow Vision AI module. So you simply need to follow this README file. So not now, like once Josh said, like this will be available on YouTube, uploaded on YouTube, this video, and later point of time, we will finish the integration. And once that is done, you have access to this repo. And then by using this repo, you can compile the firmware, you can follow these steps. There are clear steps to compile the firmware. And this point is important. So this is actually exporting the model from the EdgeImpulse Studio into this source code. So if we go back to the project that we did before, right? The face detection project. So in the deployment section, there's one block called C++ library. Right? So you click on this C++ library and then click the build button. So once you click the C++ and click the build button, it will generate 3 folders, and you need to copy and paste those 3 folders inside this directory. So after cloning this repo, you go to app, scenario app, this one standalone, then EI model, this. So you can see there are 3 folders. So these are the exact 3 same folders that will be generated by the studio before when we click the C++ block. So you just need to delete these the 3 files and replace with the files that you get from this studio. And then you just go through this, generate the UF2, upload the firmware to the Grove AI module, and then do the same as Matt did before, the edge impulse run impulse debug command, and then do the inference. So this is how. So after this, if developers want to integrate this edge impulse SDK into their own application, they can use this.
Yeah, and to add a point there, right? What the Edge Impulse SDK has inside it, it's a number of functions that are required to deploy the model, and get it running and inferencing on the target.
Yeah.
And the output of that is, is a type def struct from which you can, get inferencing results such as bounding boxes, locations of the object, within the image, inferencing time, etc. Right. And so you would use, the firmware to actually deploy for a real application, like, hey, I see a face, is it in the right location? Oh, I need to go do something now that I know that information, right? And we make this, as much as drag and drop as possible. But, if you're a coder and you're actually working on a final application, get in touch with us. We'll be happy to help you develop it and make sure that you're successful in deployment.
Right. So, okay.
And we have a few questions too when we get, we'll be sure to answer this.
Yeah, just a few minutes left. Yeah, just a few minutes left.
Yeah.
And also quickly, I want to mention about the Edge Impulse community supported boards, right? So there are some community supported boards available on Edge Impulse, and 2 of them are by Seed. Like, this is the Seed Vio terminal. So this is the Vio terminal that I just mentioned before as well. This is a Arduino based microcontroller with an LCD and a couple of sensors inbuilt, like a light sensor, accelerometer, microphone, and a buzzer. So when you connect this to Edge Impulse Studio, the Vio terminal, you can, for example, you can do like a speech recognition project because it has a microphone and it has a light sensor. So based on the light, you can do some, detection. So, and there's accelerometer. So based on hand motion recognition, you can do some AI training. So this is the board. And then we also support the Seed Recomputer Jetson, which is powered by the NVIDIA Jetson platform. So it comes with different options. So it comes with the Jetson Nano option, Jetson Xavier NX option. So different options are there. So if you want to learn more about this kind of community, these 2 boards, community supported boards, you can visit this URL, edgeimpulse.com/docs. So if you visit that, okay. So if you visit that page, so that is the same website that we use to download the CLI tools, right? This one. So if you go down, I think it's at the bottom. Okay, so under the okay, so you see community boards, and they have the Seed Vio terminal. You can go through this website to learn more about how this deployment can be done with the Vio terminal, and also the Seed Recomputer Jetson. So go back to the slide. So yeah, that's about it for this workshop. So if you have further questions, you can visit the Seed Tech Support via email. So we have the email here, and also you can visit our Discord. So you can scan this QR code to access our Discord group, or else you can visit our forum as well, so that we will be there for you to answer all your questions regarding the Seed products. So thank you everyone for listening to my presentation and the workshop. So I hope you guys were able to follow along with me throughout and understand how the Grove Vision AI module can be deployed with Edge Impulse. And hopefully you will be able to also deploy just like I did very soon once the full integration is done. and hopefully I believe that you can make interesting and very exciting projects using the Vision AI module together with Edge Impulse. So thank you very much.
Thank you, Lakshantha.
Thank you.
We do have a few questions that I've recorded. I'll answer them.
Okay.
I'll send them out here, what we had in the order they came. First of all, if you can go to the beginning of your slide deck, you had some contact information about, LinkedIn and some of your
Yes.
background.
Okay.
Somebody was asking if you could display that again. All right,
Yes.
just go ahead and just keep that on the screen.
Okay.
There was a question regarding that if you have a WIO, or sorry, a WIO terminal, can you just buy the Groove module itself?
Yes.
And how that works. Let
Okay.
me find it. Yeah, I have a
Okay.
WIO terminal already, but not the full Sense kit. If I buy the Grow Vision AI module, would I be able to use it with the same firmware?
Exactly. So yeah, there are two options, right? So if you want to use the SenseCraft firmware that I mentioned before, there are two options. One is buying the kit, the K1100 kit, right? So that is the first option. But if you don't want to buy the whole kit, what you can do is you can buy the WIO terminal separately and buy the Grow Vision AI separately, right? And then that Grow Vision AI module that you buy separately will come with the people detection model already pre-installed in the device, even when you buy it separately. You don't need to buy it with K110. It will be there with the YOLO V5 model, not the Edge Impulse. The Edge Impulse maybe will come later on, but with the YOLO V5 model, that will be there. And you buy the WIO terminal separately, and then you flash the SenseCraft, that firmware that I mentioned before, into the WIO terminal, and you connect the Grow AI, and then you can get it up and running. Or else, there's one more thing. You can visit the Grove Vision AI wiki that I mentioned before. This wiki document, this one. So this is the official wiki documentation for the Grove Vision AI module. So if you access this, you will see how this particular module can be integrated with other microcontroller boards, such as the WIO terminal. Actually, you don't need to buy the WIO terminal for this one. You can even have a different, like we have the Arduino Shao, which is a very small like microcontroller. That okay, I can show you that one right now. So we have this one. You see this kind of board. It's a very small board. It's a very, very small. So this Arduino Shao, you can directly connect with the. You see this Grow Vision AI module has 7 pin dual pin row connector. So this one can directly be on top of this one like this, and this will be ready to go solution just like this. You don't need BIO in this scenario, because this can run. This can connect with the Arduino IDE, and then it talks with the Grow Vision AI module. Yeah.
Thank you. If you could go back to the contact information again.
Yeah.
Another question I had seen, and I'll see a few more out here. Does Edge Impulse have a pre-trained model that you can use to identify particular objects, such as birds, that we can implement on the Grove AI device? So we don't necessarily have pre-trained models, right? There are models out there that have been trained to detect birds, cats, dogs, things like that. And you can run it on your computer right away if you have the necessary tooling. What Edge Impulse does is to say, you need to understand, the particular capabilities of your model, what biases they have, and, train it on the data set that you've created, right? You can, with edgeimpulse.com, import data sets like the Coco data set, ImageNet, etc., that are for those particular models. And you can bring your own custom model that you may have had pre-trained as well, or have a training framework against it. Edge Impulse is kind of device agnostic. We separate out the idea that, you need to get your model right first. And that's why we have a whole capability around bringing in data, training it, looking at its capabilities and tuning it. And then you have to figure out potentially what device you may want to deploy it to. That's where the Grow Vision AI module comes in. So we demonstrated here today that, yes, if you have trained an appropriate model to detect birds and other objects, right, or to classify them or find them on where in the vision field they are, you can definitely deploy it to the device. Here's another question I've seen. What if you want to utilize the model to trigger other Grove hardware? That's a great question. So I
That's a
think
great question.
yeah,
Yes.
we're going to do two parts here. I'll answer
Yes.
one part, and then Lakshantha will probably have a follow-up to that, right?
Okay.
The deployment option that you will eventually see in edgeimpulse.com for the Grow Vision AI module will give you a UF2, for which it was really meant to understand how your model is performing kind of more in a testing prototyping environment, right? When you're serious about and ready to deploy it into an actual application, that's when you need to get that, C++ deployment option out and integrate it into your particular coding environment. From there, I imagine you'll have to use some of Seed's tools and their SDKs and APIs in order to, link up to other particular products that they have in their ecosystem. Lakshantha,
Actually, this is this is something we are working on, like in the near future. Like, for example, our first step is to integrate Edge Impulse fully with the Grove AI Vision module working standalone, as I demonstrated in this workshop. But later point of time, we will be able to connect the Edge, the Grove Vision AI module to a microcontroller, right? And then send the data over to the microcontroller. And then the microcontroller will send the data to other places. Like, for example, you connect the Grow Vision AI to the VIO terminal, and then VIO terminal is connected to Wi-Fi, right? So the VIO terminal gets the inferencing results from the Grow Vision AI module. So, for example, it detects a person, and if a person is detected, it will send that data to the cloud, and then another Grove will be connected to that particular cloud, and it will take that information back from there. So this is something that will happen in a later point of time, but for the time being, it's not available.
So in other words, stay tuned, right, for both this integration and those features. Yeah, and we hear what you're asking for, and it's generating product features, and that's the main thing that we want to.
And it's very exciting at the moment, because from the very few weeks that we worked together, we were able to achieve something that is able to even demonstrate in this workshop, right? So and as I showed from the video before, like, we are getting really good inference performance already, and even that can be further optimized, right? So that is, we are just in the final stages. Even that could be optimized later on. So stay tuned for like a better experience with the Vision AI and the Edge Impulse.
We have another question here. It says, can the Grove LoRa module be connected directly to the Vision AI module? That is because I don't have space for the WIO terminal.
Okay. So, okay. Yeah. So we have the wiki documentation here, how to use the Grove LoRa E5. So this is the one that I showed you before, which comes with the K1100 kit. So you can visit this URL to, you see? So over here, LoRa is connected to the Arduino Shao. That's the small board I just mentioned before. So as long as the board is able to communicate with the Arduino IDE, it has the Arduino support, the LoRa E5 can be connected to that microcontroller, and then it can transmit the data to a nearby gateway. So that is how it works. So to learn more, just you can visit this.
But this board cannot be, you cannot hook up the Grove Vision as is with this LoRa board. Yeah.
The reason is the Grove Vision AI cannot be connected to Arduino. There is no library to use with the Arduino. There's no board support to use with Arduino IDE, right? Because to use LoRa, that Grove LoRa E5, we have the Arduino library to use that Grove LoRa E5. So that is how you can use the LoRa. So to use the Arduino IDE with the Arduino library, to use the Grove LoRa E5, you need another microcontroller which can support Arduino. Yeah.
Gotcha.
So that is how it is.
Yeah. I hope we answered that correctly, or per expectation, Michael. Please let me know if that's not, if you still need more information. We'll leave the questions open. I think, yeah, Michael says, got it.
Yeah.
That vision and AI in the Shaljalora. All right, looks like people are heading out. I think we're done with the Q&A session. Thank you so much, everyone.
Okay.
And thank you for coming to Imagine 2022. As always, if you have any questions, please see our website, Imagine website, and please check out Seed Studio and their great products that they have. Thank you, Lakshantha.
Thank you, Josh. Thank you very much.
Bye.
Yeah, it was great. Yeah, bye.